Hello everybody, my name is Julien Wang. I'm currently a front-end developer at Litchi in France. I'm also a Nuxt core team member, and today I would like to talk about pages. More precisely about what suffix you can use in your page file name and what behavior it will have. As most of you know, we already have suffix with components, for example, .client and .server. So .client will make your components only rendered client-side. Nothing will be rendered server-side, and your component will be rendered after hydration client-side. .server suffix will make your component only rendered server-side. It transforms it into a server-only component. So your component will be rendered server-side, sent as HTML to your browser, and no JavaScript chunk will come with it. And these two suffixes, you can use it with pages. So here I have index.view, which contains a simple counter, which is interactive. If I modify the page to index.server.view, well, the page will be rendered server-side, no JavaScript chunk will be sent to your browser, and simple counter will remain not interactive. If I modify it to .client.view, this time nothing will be rendered server-side, and your page will be rendered client-side after hydration. For people who are not using the pages directory, you can, of course, set it into the pages extend hook. So we've added a new property called mode, which accepts 3 strings. The first one is all, which is the default behavior and also the default value. So your page will be rendered server-side, then hydrated client-side. The second one is client. So this one is the exact same behavior as .client. So your page will be rendered client-side. And the last one is server, to make your page only rendered server-side. So that's everything from me. I hope you have fun at next session. See you later.
Hello, beautiful humans. Welcome back from break. Up next, let's welcome the incredible Anthony Fu to the stage. As a dedicated open source advocate at Nuxt Labs, Anthony is the creative force behind the popular projects like VTest, SlideDev, VueUse, and Uno CSS. A key member of the core teams for Vue, Nuxt, and Vite. He's passionate about advancing the community and sharing his knowledge. And when he's not coding, you can find him capturing stunning photos during his travels. Be sure to check him out on Instagram for a glimpse of his adventure. Welcome to the stage, Anthony.
Hello, everyone. Good to be here. Hello, everyone. Good to be here again at Nuxt Nation. So, for today's topic, I'd like to talk about Nuxt icon. I will walk you through various of different solutions on rendering icons on web pages, and with their pros and cons, and how we manage to find a balanced trade-off in Nuxt icon module and deliver it to you. So first, let me introduce myself a bit. My name is Anthony Fu, and I'm the core team member of Vite, Vue, and Nuxt. I'm also the creator of VTest, SlideDev, Uno CSS, and etc. I'm currently working at Nuxt Lab on the framework team. So let's talk about icons in general. What are icons? To me, they are tiny image assets that present graphics, making functionalities easier to identify and understand, while also make the UIs more interesting and engaging. However, icons are not just images. They come with their own unique requirements based on their usage. I'd say, while the concept of icons is simple, engineering them correctly is quite a complicated task. Here, you can see many icons from different collections, each with their own properties and requirements. Let's break them down from an engineering perspective. Rendering good icons comes with a few challenges that's beyond just displaying plain images. First, we need icons to be colorable. Most of icons are monochrome, but they often need to adopt their colors based on the context, such as switching between light and dark mode. It's ideal if we can change their icons, their colors on the fly. So we don't have to design multiple versions of the same icon for different colors. Similarly, icons should be scalable. They need to be fit into different sizes of screens or UI elements without losing qualities. It'll be great if we could resize them easily. Besides rendering, we also need to think about how we deliver icons. Icon set usually includes a large number of icons to cover various needs, but we rarely use all of them in a single page or app. And to improve the performance and save the bandwidth, we need to consider how we bundle them, how flexible and granular we can split the icons into chunks. Should we create chunks based on how commonly icons are used, or can we be granular enough to only ship the icons we actually use? After bundling, we need to decide how to load the icons. Should we include them in the same bundles as the client app, or as separate lazy loaded chunks? Finally, we need the capability of load icons dynamically, especially for user-provided data that we don't know at the build time. These are some of the key challenges we face with icons. Depends on your use cases. You might only need to address some of them, but when creating tools, we aim to provide a good balance to support as many scenarios as possible. So let's explore the solutions available for icons and compare their pros and cons. First, let's start with the most straightforward solution. Use the image tag. This was pretty much the only options in the early days of the web. You'd host your image assets somewhere and then use an image tag to link to that image, specifying its width and height. Here are some examples back to the days. Personally, I'm a big fan of the pixel art and I love the retro style, but probably we have to move on the design language. These are definitely some advantage of this approach using image. It's very simple. It requires no setup or no runtime dependency. It works natively in browsers. However, it also has quite some drawbacks. Image can become pixelated, meaning we don't have any color controls, and they don't scale well. Each icon being a separate image file results in many network requests, which can be slow, especially back to the days of HTTP 1. Before the image is downloaded, you might also see a flash of invisible icons, which can hurt the user experience. Lastly, it's also quite verbose to write, as you need to specify the full path of the image and manage the relative paths based on the pages. Given those downsides, it's no surprise that this approach is rarely used on the website today. And then web form becomes the second solution. As fonts are naturally by natural vectorized and callable, it soon becomes chosen for serving icons. Usually, icon set providers will compile their icons into a special font file that's assigned a special Unicode character to represent each icon, accompanied with a CSS file to set the Unicode values for each icon classes. The usage would look like this. Underneath, the CSS file would look a bit like this: a common style selector and then selector for each icons to their assigned Unicode value. The advantage of this approach is easier to use, callable, scalable, and only requires a single request to load all icons. However, the downside is that it requires a large font file to load all the icons up front, which can be slow. It's also hard to customize the icon set, and you might see a flash of invisible icons before the font is loaded, as there is no fallback font. And then, with the front-end framework comes to the game, reusing HTML elements becomes a lot easier. People come out with the idea to directly inline SVG tags as components. For icon set to support this approach, they often come with packages to provide their own wrappers for each framework. For example, MDI icons use a shared components and then provide icon data as props, while tabular icons provide components for each icon. Because they are SVGs, and they are callable, scalable, and they have all the features of SVGs. Usually, people bundle those icons into the app, so there is no additional network request, and it's even SSR friendly and visible at the first render. However, the downside is that it creates a lot of SVG DOM elements, which can hurt performance when you have a lot of icons. It also increases the bundle size, and it requires a specific integration support for each icon set and framework combinations. This implies a level of vendor locking, making it hard to switch from one icon set to another, or for frameworks as well. And to be fair, those trade-offs are usually quite good already. Many projects are using this approach today, as you don't really need to switch icon set or frameworks very often. And talking about vendor locking, I'd like to bring up this open source project called Iconify. Iconify is a unified icon framework that provides a single solution for all popular icon sets. It offers a unified collection of data for consuming, and it supports over 100 open source icon sets with more than 200,000 icons. They even provide a server API for you to fetch icons dynamically. Any icons is just one request away. The solution we are going to talk about later are all built on top of it, meaning that you don't need to worry about the icon set support anymore, and you can switch to any icon set or even mix them with zero migration needed. Iconify really did the heavy lifting work underneath to collect and normalize all these icons. I would invite you to sponsor Iconify on GitHub or Open Collective to support their work if you benefit from its ecosystem. Here I also made an icon explorer for Iconify called Icons. You can browse all the icons from Iconify collection, copy or download them as is. The URL is icones.js.org. So back to the solution we are talking about. Iconify also comes out with its own runtime solution that you can simply import the library and then use any icons as web components. Under the hood, the component will send a request to the Iconify API, and the API will serve the needed icon from the massive icon collections. This is a great fit for rendering icons from user-provided contents or other dynamic contents that you don't know at build time. And it's super easy to set up. You can even use it as a CDN without any build tools. The downsides are that it will add a runtime dependency that your icons will only render after JavaScript is loaded and icon get fetched. This also would not work for SSR or the cache layers like PWA. And with the unified interface from Iconify, combining Vit's on-demand approach, we made unplugging icons that supports you to import any icons on demand as components. Because it's an unplugging, it supports all popular build tools including Vite, Webpack, RSpack, etc. We provide compiler for all popular frameworks like Vue, React, Svelte, Solid, etc. With Iconify, we make it possible to have one single solution for any framework to use any icons. Eliminate the vendor locking on your choice of icons. So, because this is still fundamentally the same technique as the previous components icon solution, we share the same pros and cons. The difference is that with build tools integrated, we are able to serve the full collection of Iconify while only ship the icons you actually use. However, at the runtime, we still have this concern of DOM elements and so on. Then, as a side effect of creating Uno CSS, I discovered that it's possible to actually embedding icons entirely in CSS, leading the solution of pure CSS icons. This method inline SVGs as data URLs and provide a single class to display the icon. With some tweaks, the icons can become scalable, scalable, and even capable of displaying SVG animations. Browser can catch the CSS rules, and each icon will only require one DOM element to render. This approach ships icons in a single CSS file with no additional cost. Since it's pure CSS, the icon displays, along with the rest of your UIs, requires zero runtimes and works naturally with SSR. Your server don't even need to do any actual work to rendering it on the server side. The only downsides are lack of the full customization for elements inside SVGs, and also the need of bundling icons at build time, which isn't dynamic. I would highly recommend this approach for most of the cases where you don't need dynamically render user-provided icons. In my opinion, this is the most well-rounded solution so far. If you use Uno CSS, install the icon preset, and you will be able to use these features just like any other utility classes. So finally, let's talk about Nuxt. Our goal with Nuxt is to provide the seamless solutions that covers as many use cases as possible. Let's quickly go over the integration challenges we face to make Nuxt icons comprehensive. First, we need to support both SSR and CSR as they are a core feature of Nuxt. We want to ensure that icons renders without any flashes for the best user experience. We also want to support dynamic icons, such as those from Nuxt content, allowing you to use icons from your content data. Performance is crucial, so we need to ensure that our solution doesn't compromise on speed. Lastly, we want to support custom icons. In addition to the thousands of icons from Iconify, users should be able to also load their custom icons using the same syntax. With all these requirements in mind, let's compare the solutions we discussed earlier. For dynamic icons, Iconify runtime seems to be the only option. However, it doesn't work perfectly with SSR, and it doesn't support custom icons, as the request goes to Iconify servers, which are unaware of our local setup. On the other hand, CSS icons are performant and work well with SSR, but they don't support dynamic icons. So you may start to wonder, which should we choose? It's indeed tough, and it seems that either options, we are trading something that we needed. So why don't we choose both? To do that, first, we want to ease out the trade-off of rendering approach. In Nuxt icon, we provide an icon components that support both CSS and SVG mode. Both are SSR friendly. Depends on how much customization you need, you can switch between the two modes per icon. For CSS mode, the icon will be included in the CSS from SSR, while the SVG mode, the icons will be flattened into the inline HTML during SSR. Both approach allows you to render the icons at the initial screen without the runtime cost. Then let's talk about dynamic icons and how we can optimize for their loading. For dynamic icons, we can use Iconify's API, which serves any icons on demand through network requests. The downsides are that those API might be far from our users, causing some delays on rendering the icons. To improve this, if we know certain icons were going to be used anyway, we can bundle them directly into the client. This way, we can render, they can render instantly without additional requests. However, we can only do this for statically known icons. Bundling all the possible icons would make the bundle size too large. And since Nuxt is a full-stack framework, we can find a middle ground by introducing a server bundles. On the server side, bundle size is usually less than issue, so we can bundle more icon sets. During SSR, those icons can be fetched quickly and sent to the client on demand. With this setup, we can use Iconify API as the final fallback, ensuring high performance for most common use icons while also being able to serve any icons from Iconify. So let's work through the data flow to make it cleaner. We can provide the icon. So let's walk through the data flow to make it easier. Let's walk through the data flow to make it cleaner. We can provide an icon ID to the icon components to use it. The icon will first check if the icon is already server rendered. And if it is, we stop there and since the icon is already present. If not, then we will look up the client bundle for it. Most static known icons will be there, so we can render them directly. For dynamic icons that are in the client bundle, the components will then request them from our server endpoint. The endpoint is usually deployed along with your app and close to the end users. The server will look up for the request icons in the server bundles and then serve them back to the client. We have caching on both browser and API endpoint. So once one icon is being requested, subsequent requests are much faster. If the server couldn't find the icons in its bundles, it will then request the icon from Iconify and forward it to the client. In that case, caching is also applied to speed up the future requests. With all this setup, we can then load icons efficiently while support dynamic icons. So that's the approach that we are explored in Nuxt Icon 1.0. We believe we find a balance that minimizes the trade-off while offering a good user experience and flexibility. So please give a try and let us know what you think. We are excited to hear your feedback.
All right, y'all. Thank you, Anthony Fu, for joining us today. Yay! Up next, we have Mustafa Said, who is the brilliant person who will enlighten us on rank higher and faster unlock Nuxt.js SEO power. Mustafa is not only a full stack developer, he's also a full-time instructor at Vue School, where he helps aspiring developers master the art of Vue.js. Known for his experience in SEO strategies, he'll share valuable insights on how to optimize your Nuxt applications for maximum visibility. Get ready to elevate your projects, and I am stoked to learn more about SEO. So welcome to the stage, Mustafa.